In 2017, astronomers spotted something that shouldn't exist. An object from beyond our solar system behaving in ways that defied natural explanation. The anomalous visitor exhibited impossible characteristics that challenged our understanding of celestial objects. The scientific community was stunned. What if the simplest explanation is also the most extraordinary? Harvard astronomer Avi Loeb proposed a theory that many considered career suicide. This interstellar visitor might be artificial technology. Like Galileo facing the Inquisition, Loeb stood his ground as evidence accumulated. Today, we're diving into this astronomical controversy that has split expert opinion, a debate that challenges our fundamental assumptions about life beyond Earth. When astronomers at the Pan-STARRS telescope in Hawaii first spotted Oumuamua in October 2017, they knew they were looking at something unusual, but no one could have predicted just how bizarre this cosmic visitor would turn out to be. As the data rolled in, what initially seemed like a run-of-the-mill comet quickly evolved into one of astronomy's most perplexing puzzles. The object's trajectory immediately raised eyebrows. Moving at a blistering 26.33 kilometers per second relative to our Sun, Oumuamua followed a hyperbolic path that clearly indicated its interstellar origin. This extreme orbit prompted astronomers to initially classify it as Comet C2017 U1, following standard protocol for objects on such paths. But unlike previous astronomical anomalies that eventually found their place in existing categories, Oumuamua defied classification entirely. The astronomical community was collectively baffled. Where was the characteristic tail? Comets typically develop a bright dusty tail as they approach the Sun and their ices sublimate. Oumuamua displayed nothing of the sort. This absence led to a quick reclassification as asteroid A2017 U1, but even that label proved inadequate. Like a cosmic chameleon, the object forced scientists to create an entirely new category: interstellar object. The shape measurements only deepened the enigma. Based on the way Oumuamua reflected sunlight, astronomers calculated dimensions that defied conventional understanding, approximately 230 meters long but only about 40 meters wide, with a longest to shortest axis ratio of at least 5:1. We've never observed anything in our solar system with such proportions. The truly confounding aspect emerged when tracking its movement. Oumuamua was accelerating, slightly but measurably, as if something was giving it a gentle push away from the Sun. This non-gravitational acceleration amounted to a velocity change of about 17 meters per second during its closest approach to our star. While outgassing typically explains such behavior, Oumuamua showed no visual evidence of this process. Its rotation pattern added another layer to the puzzle. Unlike the predictable spin of most asteroids, Oumuamua tumbled through space in a complex, non-repeating pattern. This chaotic movement suggested an extremely unusual geometry, potentially even more extreme than initially thought. Some scientists began considering whether it might actually be pancake-shaped. Light reflectivity measurements indicated Oumuamua was unusually bright for a typical asteroid or comet, suggesting a surface composition unlike the carbon-rich materials common in our solar system. As Oumuamua raced through our solar system at nearly 60,000 miles per hour, astronomers gathered as much data as possible. The combined anomalies, extreme shape, unexpected acceleration, absence of a tail, unusual brightness, and chaotic tumbling, created a perfect scientific mystery. Our existing categories and natural models struggled to accommodate this interstellar visitor, leaving scientists at an uncomfortable crossroads. Enter Avi Loeb, the scientific rebel with impeccable credentials. As a tenured Harvard professor who chaired the astronomy department for 9 years, Loeb stands as a theoretical physicist with over 1,000 published papers and someone who had chaired the board of physics and astronomy of the national academies. Like Galileo before him, Loeb's willingness to challenge scientific orthodoxy has placed him at the center of astronomical controversy. What made Loeb's approach so provocative was his methodical reasoning. While his colleagues scrambled to explain Oumuamua within conventional frameworks, Loeb took a different path. He meticulously examined the anomalous properties, the extreme shape, the mysterious acceleration without visible propulsion, the light curve suggesting an unusually reflective surface, and found the natural explanations wanting. People often say extraordinary claims require extraordinary evidence, but they are not seeking the evidence, Loeb remarked in his TED Talk, articulating the fundamental disconnect between scientific caution and exploration. So let's just look around. This statement encapsulated his scientific philosophy. Don't dismiss possibilities before exploring them. Instead of forcing Oumuamua into existing categories, he allowed himself to consider what others wouldn't, that we might be observing something artificial. In his 2021 book Extraterrestrial, Loeb carefully positioned his hypothesis. It's more of, let's imagine what's possible and allow it, not dismiss it ahead of time. This represented a reluctant consideration after methodically ruling out natural explanations. His reasoning resembled Sherlock Holmes's famous principle: when you have eliminated the impossible, whatever remains, however improbable, must be the truth. The light sail theory that Oumuamua might be a thin artificial structure propelled by starlight emerged as the explanation that best fit the observations. The reaction from the scientific community was swift and fierce. Some colleagues questioned his conclusions and whether such ideas should even exist within scientific discourse. Stephen Desch stated, Loeb is on a mission to find aliens. He believes he sees something in the data hundreds of experts don't. This resistance follows historical precedent. Galileo faced house arrest for supporting heliocentrism. Continental drift was ridiculed for decades before plate tectonics became accepted theory. The pushback against Loeb exposed deeper questions about scientific orthodoxy. How should science approach extraordinary possibilities? What burden of proof is appropriate for unique events? Rather than retreat, Loeb established the Galileo Project, a research program designed to search for extraterrestrial technological artifacts. Backed by millions in private funding, including from cryptocurrency magnate Charles Hoskinson, Loeb created a pathway to continue his research outside traditional funding channels. While Loeb's theory set intellectual wildfires across academia, the scientific establishment wasn't simply dismissing him without offering alternatives. Every natural explanation proposed for Oumuamua solved one mystery while creating another. like a cosmic game of whack-a-mole where each answer raised new questions that nobody anticipated. The hydrogen iceberg theory emerged as a serious contender. Darrell Seligman and Gregory Laughlin proposed that Oumuamua's acceleration resulted from hydrogen sublimating from its surface. This elegant solution faced a fundamental problem. Hydrogen icebergs would likely evaporate during their interstellar journey, dissolving long before reaching our solar system. Additionally, such sublimation should have produced a visible cometary tail, which telescopes never detected. Alan Jackson and Stephen Desch suggested Oumuamua was a nitrogen ice fragment similar to Pluto's surface, essentially a chip off an alien Pluto. This addressed several peculiarities, but required an implausibly high mass of such objects throughout the galaxy, exceeding reasonable expectations based on planetary formation models. Yun Zhang and Douglas Lin theorized Oumuamua might be a fragment from a planet torn apart by tidal forces. While this explained its rarity, the model predicted cigar-shaped objects, contradicting light-curve data suggesting a more disk-like form. Each natural explanation resembled a puzzle with critical missing pieces. In 2023, Jennifer Bergner and Darrell Seligman proposed that hydrogen outgassing from water ice could explain the acceleration. Their theory suggested cosmic ray particles had altered Oumuamua's surface during its journey, causing hydrogen buildup in the water ice matrix. This remains promising but leaves questions unanswered. The scientific community's response highlighted how science handles unprecedented phenomena. David Jewett and Michelle Bannister offered alternatives while acknowledging a humbling truth: the data was insufficient for definitive claims. The debate extended beyond Oumuamua itself. What constitutes extraordinary evidence when studying a visitor observed for mere weeks? While most astronomers reasonably demanded overwhelming evidence for extraordinary claims, this methodological conservatism might have prevented recognition of something revolutionary. Oumuamua created a fundamental challenge by retreating beyond telescope reach before comprehensive data gathering. Scientists were reconstructing an entire dinosaur from a single tooth, an impossible task inviting multiple interpretations. This astronomical curiosity evolved into a test case for handling scientific ambiguity. The controversy established new observation protocols for future interstellar visitors and spurred funding for dedicated research initiatives. Most importantly, it sparked conversation about whether our preference for natural explanations is always scientifically justified or sometimes just intellectually comfortable, placing Loeb's hypothesis in stark contrast with conventional scientific approaches. That conversation about natural explanations versus extraordinary possibilities didn't just remain theoretical. It materialized into Harvard-based hardware, AI systems, and expedition teams searching the Pacific floor. In July 2021, Avi Loeb transformed academic debate into concrete action by launching the Galileo project, a systematic search specifically designed to find physical evidence of extraterrestrial technology. This represented a fundamental shift in how we might detect potential alien civilizations. The Galileo project emerged directly from the controversy surrounding Oumuamua, which challenged traditional astronomical explanations. Like Galileo himself, who faced resistance when suggesting Earth orbits the Sun, Loeb's willingness to consider unconventional hypotheses puts him at odds with scientific orthodoxy. What makes the Galileo project revolutionary is its approach to funding and institutional independence. Loeb secured approximately $5 million from private donors fascinated by his hypothesis about Oumuamua. This financial model allowed him to bypass traditional scientific funding channels that typically avoid speculative research. He created an entirely new research apparatus while maintaining connections to prestigious institutions like Harvard. The project boasts impressive leadership, including Frank Lorkian, CEO of Bruker Corporation, with advisors Charles Alcock from Harvard-Smithsonian's Center for Astrophysics and Seth Shostak from the SETI Institute. This combination of academic and industry expertise ensures both scientific rigor and operational flexibility. The technology deployed is sophisticated and purpose-built. The project uses telescope arrays with infrared cameras, optical cameras, and radio sensors connected to AI-powered analysis systems. These instruments are calibrated to identify objects with unusual characteristics, suggesting artificial origins. The project established its first observatory at Harvard with plans for a second in Colorado. Scientific reactions have been divided. Some express enthusiastic support, while others worry about astronomy's reputation. Loeb stopped being a scientist some time ago, yet Loeb has found supporters outside academia, including cryptocurrency magnate Charles Hoskinson. The project has expanded to include searches for unidentified aerial phenomena and potential interstellar objects in Earth's oceans. In 2023, during a tense expedition near Papua New Guinea, Loeb's team recovered metallic spherules from the ocean floor. As researchers carefully extracted these tiny objects from sediment samples, the weight of possible discovery hung in the air. Analysis led by Harvard geochemist Stein Jacobson suggests these spherules have a chemical composition of unknown origin, though skeptics counter they might be molten blobs generated by an asteroid impact. The Galileo project represents a shift from traditional SETI's focus on radio signals to finding physical artifacts, archaeological remains of advanced technology. This approach acknowledges that interstellar travel might be possible for advanced civilizations, and that physical evidence could persist long after its creators have vanished. As we reflect on the Oumuamua saga, we're witnessing science at its most fascinating in both the discovery itself and our response to the unknown. The controversy has sparked a profound overhaul of our readiness for interstellar visitors. Scientists are developing rapid response protocols specifically for these cosmic travelers. Loeb's hypothesis, though controversial, created a scientific community that better balances caution with imagination. The space between skepticism and wonder remains our most fertile ground for discovery. When the next interstellar object appears on our cosmic horizon, like a ship emerging from uncharted waters, we'll be watching with new instruments, protocols, and more open minds.